we're going to practice some more of these writing the equations from the graph, okay, like we did one of these yesterday. But before we do that, I just wanted to review here Mr. Berry's chart. Remember this chart that we talked about yesterday? So I'm going to keep referring to this. So you kind of want to take a mental picture of this. So we have sine. This is a chart is on page what? Page 4. All right. So sine versus cosine, and then positive versus negative. So we got sine always starts at the midpoint. And if it's positive, it does the hill first. If it's negative, it does the valley first. Okay. And then cosine, if it's positive, it starts at the high point. If it's negative, it starts at the low point. Cool. All right, so let's keep that in mind because the first thing I'm going to be doing is referencing this chart and which one of these 4 it is. All right. Cool. So number 2 here then, we'll first kind of think about what type of graph is this, okay? Is it sine or cosine? Is it positive or negative? I'm going to write that down in a second, but I'm going to give you guys a second to think about it. Which one of those 4 from that previous chart is it? To me, it's got to be positive cosine. All right. So next up, I told you to look for an up-down shift, and how you look for that. The midpoints, are they at what's the y value of the midpoints? In this case, I think that they are still at a y value of 0. I actually think we're not going to see any up-down shifts here. If you kind of look back to how the question is written, they don't have like I think it was the C. We don't have a number adding or subtracting in the back. So that's telling me that on these questions, we're not going to have any up-down shifts. That's okay. Still going to kind of point it out here. All right, the amplitude, the distance from the midpoints to the high points. That's usually pretty easy to see, I think. So in this case, it's going to be 3/2. A y value of those high points, really, if your midpoints are at 0. All right, horizontal shift. Zero. Okay. That's like the starting point. So what's the x value of the starting point of the period? So we can see it kind of starts right here. The x value there is 0. We will be seeing some horizontal shifts on the next 2 questions. So if you're looking for what that looks like, hold up a minute. All right, the period on this one is a little tricky. I know that the period is really this line right here, because that's like the end of the period. You can see it matches up with the top there. But they didn't tell me what that line is, correct? Okay. Can I figure out that line? I'm going to say yes. So we have this first. So they put the grid marks here. Looks like there's, this is the 4th one is what we're looking for. The first one you can see is pi over 6, correct? So if they label the first one as pi over 6, that means that like the distance in between each grid line has to be pi over 6. So this one's 1 pi over 6, which means this one is 2 pi over 6. Now, can I reduce 2 pi over 6? Yes. Do I want to? Actually, not really, because it's going to be easier for me to just think of it as 2 pi over 6 so I can keep the count going here. So I have 1 pi over 6, then it's 2 pi over 6. This one should be 3 pi over 6. Is it 3 pi over 6? I'm actually going to argue yes, because 3 pi over 6 reduces to pi over 2, correct? So that actually is 3 pi over 6. Just going to make a note of that. And so that means that this one must be 4 pi over 6, okay? So there's 4 lines, each of them's pi over 6. That's pretty logical here. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Now I'm actually going to go ahead and reduce that to 2 pi over 3 when I write my actual period. Okay, now remember the period doesn't actually go into the equation. K goes into the equation. So we have to take the period and set it equal to 2 pi over K to figure out what K is. Now, in number 1 for these, I told you that a lot of times it's super easy. You can kind of just look at this and use logic to figure out what K is. I think that this is another case where, to me, if I look at that, 2 pi over 3 equals 2 pi over K, doesn't K have to be 3 in order to make those two equal? Like if we're going to balance out those two sides of the equation, then I'd have to put a 3 there for K in order to do that, okay? There are going to be some on the next page where we cannot do this in our head, and so I'll show you how to actually solve it. You would do like a cross multiply, so you would do this times this equals that times that, and you could solve it like that, okay? Okay, so we have all the information we need to write our equation now, so I'm just going to kind of bubble it in here. And I'm going to have you guys try to write the equation. So we have a positive cosine graph, amplitude of 3 over 2, K value of 3, all right? So let's see if you can write your equation based on those 3 pieces of information. I'll give you about 15 seconds to do this, and then we'll go over it. But try it on your own first. Go. All right, so we get y equals 3 over 2 cosine 3x. There you go. All right, so let's try it again. Let's do number 3. So already what's jumping out at me is the left-right shift. So you guys, I think you can see here that this one is starting at negative pi over 3. It's starting back there. All right, so I'm going to incorporate that. But before I do, we got to think about Mr. Berry's chart. What type of graph is this? Sine, cosine, positive or negative? Once again, keeping in mind that we're starting, this is our starting point. The furthest left on the period is the starting point. All right. So for me, this has got to be a negative cosine. Josh here in class agreed with me. So if we got 2 of us, feels like it's got to be right. Starting at the low point, of course, we're talking negative cosine. Absolutely correct. All right, our midpoints at a y value of 0. So we don't not have an up-down shift. Amplitude is 1/2. All right. We do have a horizontal shift. And so that is to the left, pi over 3. All right, period on this one is kind of tough. So we know the period, it's a horizontal distance from here to here. All right. Now, if we're starting at 0, then the period is just whatever's the last x value, okay? So if we started this one at 0, the period would just be 2 pi over 3, but we did not start at 0, right? So what I would do in these cases when you don't start at 0, I would subtract the x values of the end of the period minus the beginning of the period. I don't know how to spell beginning, so I'm just going to say start. That's what I do when I don't know how to spell a word. I just think of a different word that means the same thing, but it's easier to spell. All right. Because I'm barely literate. Barely. All right, so where does this period end? It ends at 2 pi over 3, x value. Where does this period start? It actually starts at a negative pi over 3. Well, minus the negative, we all know is plus. These already have a common denominator. So the period is 3 pi over 3, which I would really say is just pi. All right. So next up, we have to calculate k. So we're going to do the period equals 2 pi over k. Now this one, I'm going to say some of you can probably logic this out. Some of you could probably look at that and think, oh, I know what do I have to put in there for k to turn that into pi, to make it equal pi? And I'll bet some of you can think of that right now. If you can't, then I'd say let's multiply the k over to the other side. So we got k pi equals 2 pi. K pi, also my favorite like genre of music, like some BTS, you know, k pi. So k pi equals 2 pi, divide by pi. So k equals 2. So once again, going back to that first step, some of you may have like seen that at the beginning, be like, okay, k's got to be 2, and that's fine. All right, so this one's a little trickier, but let's see if we can do it. Let's see if we can write an equation here. We need it to be a negative cosine equation. We need an amplitude of 1/2. We need a horizontal shift of pi over 3, and we need a k value of 2. So all of that, 4 pieces here. I'll give you 15 seconds here, see if you can do it. All right, so I get y equals negative 1/2. Even though the amplitude is positive 1/2, I have to put negative because we said this was a negative cosine graph. So I'm going to put cosine. Now, when you have a k value with a horizontal shift, you always put the k value, then open up the parentheses, then put your shift. So there we go. It's x plus pi over 3. Remember, with the left-right shift, it's kind of always the opposite of what you would think. Plus is left and minus is right. So there's our answer. Okay, let's do one more here. So first of all, what type of graph do we got? Sine, cosine, positive or negative? According to my chart, I would say this looks exactly like the positive sine graph. We're starting at a midpoint, going up and then back down. Again here, like I said, I don't think we have an up-down shift. The y values are 0. Amplitude, I got it at 4. For the horizontal shift, I have left 1/2. Now this X scale is a little weird here because all of our other X scales have had like pi involved and this one does not. That doesn't mean that it's wrong. That doesn't mean I should like put the pi in myself. Okay. It does happen sometimes. And so let's talk about what it looks like when it does. Okay. So horizontal shift is left by 1/2. And then the period here, we can use the same kind of trick we learned last time. When we're not starting at 0, I would just do the end minus the start. So 1 minus a negative 1/2. Of course, we're going to need to make a common denominator there. And so the period is 3/2. Okay. So 3/2 is the period. Remember that the period is kind of the one thing that's not really in the equation. We have to use that to find K. So we always set the period equal to 2 pi over K. And then now we're going to have to solve for K, all right? So this is the one, I think even me, Mr. Barry, literally a math genius, I probably couldn't do this one in my head just by looking at it. I would have to solve it, okay? So how do we solve this? I would cross multiply it. So 4 pi equals 3K. Whenever I cross multiply, I always draw a butterfly head there because it makes it prettier. There we go. Very important. All right, remember we're trying to isolate K here, correct? Trying to figure out what K is. So I'm going to divide the 3 over. So K equals 4 pi over 3, all right? And this will happen anytime that there's no pi in your X scale. It means that there's actually going to be a pi in your K value. Because if you put the pi in your K value, it actually takes it out of the X scale. It takes it out of the period. All right, so what's our key information here? K value, amplitude, horizontal shift, and a positive sine graph, okay? So with those 4 pieces of information that I've bubbled there, let's see if we can write an equation. It's going to look pretty similar to number 3. Ready, go. All right, so I got y equals 4 sine 4 pi over 3 parentheses x plus 1/2. Awesome. All right, that was fun. So that'll kind of conclude our notes on sine and cosine graphs. So I hope you can see why we kind of group those two together, because they are very similar. You find the amplitude the same way, you find the period the same way. The graphs generally look the same. So now we're going to shift on to our next and last graph we're going to do here, which is tangent of x, okay? And so this one we kind of look at separately because there's a lot of differences in this graph, okay? All right, so y equals tan x. This is what one period looks like here. It looks like this, okay? This is what one period looks like. I think it looks a lot like if you remember the cubic graph we did first semester, y equals x cubed. It's kind of a squiggly here. A key difference, though, is what I think is the key feature of the tan graph, which is the vertical asymptotes. The cubic graph does not have vertical asymptotes. This graph does. We learned a little bit about vertical asymptotes last semester. So vertical asymptotes is like an imaginary line that the graph gets closer and closer to, but never touches. So it has it on each side here. So as it's going up here, it's going to keep going up. There actually should be arrows. So I'm going to go ahead and draw these arrows in. So this piece of the graph is going to go up and up forever. It's going to get closer and closer to the x value of pi over 2, but never actually get there, okay? Same thing as this going down. The other thing that's interesting about this is, remember, this is just one period, right? So if you go over to the left column here, you'll see, remember that the periods repeat themselves, correct? So not only is there this one in the middle, there's another one to the right. After that, there's another one to the right of that, and another one to the right of that, forever and ever and ever, right? This pattern is going to keep repeating itself. Also, will repeat itself to the left. All right, one more key difference here between sine, or a couple more, between sine and cosine and tan. And this is very important, so I'd like you to write this. The period for tangent is pi over k. So that is different. Does that mean that I told you guys sine and cosine wrong? Do we need to go back and change what we did on that? No. Sine and cosine is still 2 pi over k, but tangent is pi over k. So that is different. It's half as long. Another key characteristic on this one, amplitude is none. There is no amplitude, okay? I think there actually may be some Webbestein questions that ask you the amplitude on a tan graph, and it's kind of a trick question, all right? Remember, amplitude is the distance from a midpoint to a high point. Where are the high points on these ones? Well, they're infinite. This graph goes up forever. There is no high point. So there is no amplitude, okay? Awesome. And then, yes, we have repeating asymptotes. The first one is at pi over 2, and then it keeps repeating itself. All right. So let's take a look at what the transformations on this look like. So when we have something like y equals 2 tan of x, obviously that's not changing the amplitude because, like I said, the amplitude, there is no amplitude on these ones. It just kind of makes it steeper. So you can see here the blue graph is the original tan x, and then the red graph is just a little bit steeper, okay? Then negative tan x flips it upside down. The thing I always notice about the original tan graph, which here is in blue, the original tan graph is always increasing. Do you notice that? So it starts down here and then it increases. It starts down here and then it increases. So then the negative tan graph is always decreasing, 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 okay? Okay, so then we can change the period as well. So you can see for this one, because we have a k value of 2 now, the period would be pi over 2. And this one actually as well. Remember on tan graphs, the period's pi over k, as opposed to sine and cosine, the period is 2 pi over k. The thing I would actually like you guys to start thinking about, what I found makes graphing tangent a lot easier, is actually figuring out what is the half period. So an optional extra calculation that I'm going to be doing here, if you want to do it in your head, I think that's fine, but I'm going to be showing it, is if the period is pi over 2, then the half period would be pi over 4. If you double the denominator, that's half, right? And the reason that I would like to calculate the half period is that on the tan graph, the starting point, if there's no left-right shift, is always going to be at 0, 0, right in the middle. And then from there, from that middle point, you're going to have a half period on the right and a half period on the left. So if you have half a period on the left and half a period on the right, I think logic says that that is a whole period. But since the periods are kind of held in by asymptotes here, that's why I kind of want them on each side. So we put pi over 4 on the right, asymptote. Pi over 4 on the left, asymptote. And that gives you the whole pi over 2, all right? So this one, the next one's the same idea here, except that starting point gets moved to the right, pi over 4. So that's the only reason that the starting point wouldn't be at 0, 0 is if you have a shift. But you can still see we have the half period to the right would be pi over 4. The half period to the left would be pi over 4. And that's where your two asymptotes are. All right. So these two just explain how they drew those. So if you'd like to read those later, you can. Okay, so this one I'm matching the graph with the equation. So this one I see we have a reflection, which means for tan, it's going to be decreasing. So I would see right away that that's number 2 there. You can see this graph is decreasing the whole way. You can see the key transformation here is a shift to the left, pi over 4. So we can see that our starting point here is at negative pi over 4. And so then I know that's number 1. So yeah, you should have a point on the x-axis. It's usually at 0, 0, unless there's a left-right shift. Even on the reflection, you can see we still do have that point at 0, 0, correct? It's only moved from there if we have a left-right shift, okay? So that's what you're looking for on those ones. All right, so now let's graph a couple on our own here. And then we'll be done. Okay, so number 3, looks like we have a period change here. So the period is going to be pi over 3. I'm going to identify the half period again. So I said you can go ahead and just double the denominator. That's going to be pi over 6. I do not have a left-right shift, so I'm going to put my dot at 0, 0. I'm going to go a half a period to the right, draw an asymptote. Half a period to the left, draw an asymptote. Draw my little squiggly there. Looks good. Nice and easy. Okay, this one right here, the period is pi over 1, which would just be pi. The half period is going to be pi over 2. Then we do have a horizontal shift here to the right, pi over 4. So I'm going to go to the right pi over 4, and there's my starting point. It's actually kind of my middle point, right? All right, then I'm going to draw an asymptote over here, asymptote over here, draw my curve. But I need to identify where these asymptotes are. So remember, from my middle point there, I go half a period to the left and half a period to the right. So I need to add pi over 2 to pi over 4. I'm going to need a common denominator for that. So I'm just going to say right here, okay, I'm really doing 2 pi over 4 each way, just for a common denominator's sake. So if I have pi over 4 plus 2 pi over 4, that means this one's at 3 pi over 4. If I have pi over 4 minus pi over 4, that means this one's going to be negative pi over 4. Just find that half period, find that middle spot, add the half period to the right, subtract the half period to the left. There's your asymptotes, okay? Draw the graph. Cool. Does Mr. Barry have a meme for tangent graphs? You bet your asymptote. There it is. Tan lines. Boom. That's actually a picture of me like 10 years ago. I put that sunscreen on my back like that so I could create this meme. That's dedication. That's actually not true. That's not me. I found this on the internet, okay? All right, cool. I always wear sunscreen because I'm super white and I don't want skin cancer, okay? All right, cool. So